All right, welcome everyone, and welcome back for those of you joining us for day 2 here at Fierce Wireless 5G Blitz Week. It's great to see so many of you on. My name is Alejandro Piñera. I'm your host today and throughout this week, and it's my pleasure to join you here again. Before we get started with today's session on Open RAN, I'd like to thank our sponsors as always, Analog Devices, Ericsson, Sankey Labs, and Viavi Solutions. Well, we have a very busy 90 minutes ahead of us here to discuss the deployment challenges, but also opportunities for Open RAN and deployments. We'll kick off in just a few seconds here. We'll hear from Atusa Hetefi. She is the head of software and RAN architecture at Orange, and she joined us live for her 15-minute keynote. We'll then hear from Mike Murphy, CTO at Ericsson North America, and that'll lead us into our live panel. Our live panel is hosted by Peter Jarek from GSMAI, and he's joined by speakers from Analog Devices, Ericsson, Sankey Labs, Deutsche Telekom, and the Open Networking Foundation. Following the panel, we'll hear from Reza Vaezgemi from Viavi Solutions, and Reza will close out on his views on Open RAN deployment. As always, we welcome and encourage your input and your discussion points. You can speak to your fellow attendees and to the speakers over on the chat window on the left-hand side of the screen. And if you do want to send questions to our moderators, but also our speakers directly, you can do so using the Q&A tab on the left-hand side of the screen, just above the chat window. Well, that's enough from me now. Let's head over to the people who really know what they're talking about when it comes to Open RAN. So here we go, live. Joining us is Atusa Hetefi from Orange. Atusa, over to you.
Thank you. Thank you for the introduction. So I'm very pleased for this opportunity to talk about Open RAN challenges during this session. We in Orange, we are actively involved in the development of the ecosystem for Open RAN, and I'm personally involved in the coordination with the technical Open RAN group on behalf of 5 major European operators. And by the way, we have recently published, actually last week, the second release of our technical priorities. So I will present now our vision on the main drivers for Open RAN and the associated deployment challenges. Let's start with the main Open RAN pillars, actually. So the first, we see 3 main pillars for Open RAN. The first one, open interfaces. Open interfaces would allow us to mix and match vendors, leading to faster innovation, leading to vendor diversity. And one of the main open interfaces that is of importance for us is the open frontal interface, which gives higher operational flexibility, and also it eases vendor swaps. And it's particularly of interest in the context of 5G. Where in 5G with massive MIMO radio units and open frontal, we can consider keeping the radio units and only swap the vRAN software vendor. There is one particular challenge in this context, and it's related to the fact that Open RAN doesn't actually apply to legacy technologies, 2G and 3G. And thus, as long as we have these legacy technologies in our network, we need to find other workarounds to manage them. As an example, we can mention the overlay architecture. So it adds somehow to the operational complexities from operators' point of view. Second pillar is Cloud RAN. Actually, to make the most of the generic hardware, which leads to a kind of economies of scale. Cloud RAN also eases the centralization of the different network functions at the edge data centers, and this would allow us benefiting from pooling gains, benefiting from some advanced radio features through site coordinations, which would allow us to improve the end user performance as well. But when we are talking about Cloud RAN in the context of 5G and massive MIMO, there are some extra requirements that needs to be taken into account, particularly the need for high performance and energy efficient hardware accelerators. This is something that is not yet largely available in the ecosystem, and we expect that from end of 2022 onwards, this would be largely available and mature enough. Another important aspect related to Cloud RAN is the centralization. Actually, centralization comes with some challenges for operators, particularly brownfield operators, in terms of impact on the information system that needs to be clearly assessed. That's why for the initial deployment we consider mainly a kind of distributed architecture before moving towards this centralization. And finally, the intelligence. Actually, it's to unleash the full potential of an intelligent and automated network, thanks to the radio intelligent controllers and thanks to kind of orchestration in a cloud native environment. Actually, through this automation and intelligence with Open RAN, we could improve the spectrum efficiency. We could optimize further the radio parameters in real-time way, and overall it leads to a kind of smart CapEx and OpEx. But the challenge here is that all of the associated interfaces are not yet fully available from specification point of view, not yet mature enough. So it's something that is still under development. Now let's take a look at the main Open RAN use cases from operator point of view. So we distinguish three main use cases. Let's start with a macro one. So our vision is that in macro, the rural use case is the promising one for initial deployment before moving to a wide-scale type of deployment in urban areas. Because the urban type of deployment needs to be considered when Open RAN is mature enough, particularly in terms of feature parity with traditional RAN, when it is on par in terms of performance with traditional RAN, and also it needs to be at least as energy efficient as the traditional solutions. Another use case is indoor. Actually, Open RAN can be considered in B2B use cases, and also it is an interesting alternative for multi-operator distributed antenna system. Open RAN actually simplifies a lot the architecture of multi-operator indoor deployment. It actually removes the several duplicated components that exist today in legacy architectures, and it leads to it reduces a lot the required space and the energy consumption. But overall, the volume for indoor type of deployment is less than the macro use case. And finally, another very promising use case with Open RAN is RAN sharing. Actually, with Open RAN, operators will be able to share the OCloud infrastructure, the cloud infrastructure, as well as the radio units. But at the same time, they can keep their differentiation through separate choice of RAN vendors for the software, for the RAN software, and separate management of the software. So that's why it's very interesting, and we expect that the standardization of this promising use case will be finalized before the end of the year, which would allow us to consider this type of deployment with Open RAN from 2023 onwards. So actually, so far I addressed mainly the challenges of Open RAN related to the Open RAN pillars and deployment use cases. On top of that, I would like to address some few other elements related to Open RAN that needs careful attention. One of them is security aspects. Actually, there's a change of paradigm with Open RAN on security. We are moving from security by obscurity to a security by transparency model with Open RAN. Actually, there are some inherent security risks with Open RAN. The fact that we have the threat surfaces actually with Open RAN increases with just disaggregated our architecture. We will have a multiplicity of vendors. We'll have multiplicity of interfaces in an open environment. So there are some baseline that needs to be considered with the Open RAN approach to manage security. It could be through zero trust architecture, which actually is based on never trust and always verify model, and it relies on a kind of mutual authentication between different elements to communicate to each other. There is also a risk-based approach, which is built on threat modeling and remediation analysis, which complements the 3GPP approach. And finally, there is a higher reactivity, thanks to the CI/CD chain, which allows a kind of faster deployment of patches to fix security vulnerabilities. The security focus group in the ORAN Alliance, which is actually developing the main security specifications for Open RAN, considers all of these main principles in the development of security requirements and testing. On top of that, in the context of the Open RAN MOU initiative with European operators, and also in the context of our collaboration with TIP on Open RAN, we give a particular attention to security, to develop and to identify and develop security requirements that needs to be implemented and needs to be tested in the Open RAN solutions. Another important aspect that could be challenging with Open RAN is interoperability. Actually, both standardization and interoperability testing, IoT testing, are necessary or required for Open RAN. Open interfaces have been specified, and the specifications are becoming more and more mature. But I mean, this is a prerequisite, of course, but it's not enough. It's not the end of the road, because if you look at the current situation and the specifications, we see that there are several options, several profiles that exist, and if you want to have truly interoperable interfaces, we need to consider some guidance, clear guidance from operators that indicate the real needs and the real deployment scenarios, concrete deployment scenarios. And this is actually one of the objectives of the work that we have done in the context of Open RAN MOU with European operators. We give actually this guidance through prioritization of the profiles and options that are important for us for our deployments in Europe. And in order to test all of these, let's say these Open RAN solutions against our requirements, against our prioritized profiles, we in Orange launched several initiatives. We have inaugurated last year the Open RAN Test and Integration Center in France, and we have also launched other initiatives such as Cloud Native Experimental Operator, which is called PICO, in which we can test different Open RAN solutions and assess the maturity and their readiness for commercial deployments. So testing of Open RAN solution is important, including IoT testing, and but actually it comes with some cost. So it's important at the same time to share the burden between operators. So we need to have kind of coordinated testing activities, for example, through the ORAN Alliance Plugfest or through TIP Community Labs, in order to share the test results between us. And this would definitely help us to save time and cost for these activities. And finally, I would like to mention another important challenge, which is related to integration and SLA in a multi-vendor environment. Actually, we can say that clear responsibility metrics actually in terms of troubleshooting or SLA assurance needs to be defined, but it's not that much straightforward when we are in the Open RAN context. We can consider different models actually for these responsibility definition. One model is based on the operator that has the role of integrator. In such case, the operator actually needs to have separate SLAs with different vendors. And in such context, we need to consider more and more integration and IT skills within the company, and we won't have any single point of contract for the end-to-end quality of service. On the contrary, there's another model which relies on a third party for the integration. It could be either the vRAN vendor or the system integrator who takes the full responsibility of ensuring the end-to-end SLA. So in this context, actually, even if we could have several vendors in our Open RAN solution, at the end, we would probably have a limited number of options to pair vendors together, which would depend on actually the actual preferred vendors or of integrators or their pre-selected vendors. So that's one point that needs to be taken into account as well. So these are the pros and cons of these different models that need to be evaluated by each operator in order to choose the final integration model. And with this, I conclude my presentation on the Open RAN challenges. Thanks for your attention.
Great, thank you very much, Atousa. Always good to hear from Orange as one of the leading operators when it comes to Open RAN and, of course, so many other things. Right, next up, we're going to hear from Mike Murphy, who's the CTO for North America over at Ericsson. Mike, over to you.
Thank you, Alejandro. So what I'd like to do today is look at the status of the specifications in the ORAN Alliance and some of the deployment challenges coming forth. So just to set us all on the same page, same foundation. So the ORAN Alliance was founded in Shanghai 2018. It was a combination of XRAN from the US and CRAN from China. It's actually a German entity, a German legal entity. The Alliance leadership, the chairman is from AT&T, it's Andre Fuchs, and the head of the technical committee is from China Mobile, Dr. Qi Lin. There's 31 operators, 295 contributors. There's 10 working groups and 4 focus groups. You know, arguably one of the more important working groups is Working Group 4 that's specifying the open fronthaul interface, but also number 2 and number 10, which essentially define an SMO and some real-time, non-real-time applications are also very important, as is the security focus group. Now, you'll see lots of complex diagrams of the ORAN architecture from the ORAN Alliance. I'll give you my version, which is a little bit simpler. And I kind of divided into 2 basic components. First is net new capabilities. So this comes from the service management and orchestration part of ORAN and RAPs. So this provides network intelligence added through RAPs and a simplified SMO multi-vendor management capability. So arguably you could have done that multi-vendor management before, but there's better interfaces, more data available to do it in a slightly better way now. And the RAPs capability is somewhat akin to CSON or SON, and that's a net new capability. So that this component of ORAN adds value to the network. For the lower part, the fronthaul interface, which enables a mix and match of RU, DU, and CUs, while ORAN doesn't specifically mandate a virtualized solution, there's kind of a de facto assumption that ORAN deployments for the CU and DU will be virtualized. So that's a very high value, as noted previously, but it's not strictly speaking from ORAN. For the fronthaul interface, the very famous Working Group 4 fronthaul interface, there's actually no performance benefits you get from implementing that. So there's not a net new capability. So the value really is in this ecosystem evolution and allowing more of a mix and match of vendors. But if you're deploying a network and want to compete by adding new capabilities into your network, a new fronthaul interface isn't going to do that. But an SMO with RAPs will help you do that. In terms of specification status, I've shown the version numbers here on the left-hand side, and you can kind of see that the fronthaul interface there, which is at version 8.0, is, you know, it kind of gives you an indication of maturity. Likewise, the profiles for the 3GPP interfaces on the bottom there in light gray, they're fairly mature as well. And then you have a little bit of a mixed bag going across the other interfaces and the results of the focus groups. Notably, O1 is at 6.0, so that made me give you a feeling that it's mature. However, the data models aren't quite complete yet, so there's still a little ways to go there. So I think what you'll see, and I'll explain next, is there's a progression of maturity over time. Now, some of the more important points, the alliance was formed in 2018. The head of technical committee chair, Dr. Chi Lin, she mentioned in light reading panel at the end of November last year that full maturity of all aspects of the ORAN specifications will come close to 6G. So that kind of gives you an ending bracket, and then we have maturity of different components happening in between. Germany's cybersecurity agency, BSI, indicated that the specifications as is, actually increase security risks. So some work needs to be done there, as mentioned in the previous keynote. Also, while there is good maturity in the current frontal spec, often referred to as 7-2X, there is a new frontal spec that was proposed by, in particular, AT&T, that's being worked on. And this will provide higher performance, particularly in uplink, and help reduce costs in certain situations. So these are two quite big improvements that are needed going forward. By the way, Ericsson is a major contributor to driving the specifications. We were the #1 contributor in 2020, the #2 in 2021. And on these particular items noted here, so the security elements and the high performance frontal, we're one of the major vendors driving them. So I think you can safely say that the ORAN specifications actually wouldn't be where they were without Ericsson and the other incumbent, Nokia. So it's a little bit false statement to say that we're not supportive of this direction. So I put this on a kind of a timeline. So as I mentioned, we have these brackets, the Alliance Form 2018, full maturity 2030, and then the different specifications between those 2 points. Now, it's good to put that on an overlay of the bigger picture of what's really happening in networks today. So we had most launches in April of 2019, and then there's been some coverage development since then. I think the really big push on coverage started in 2021. We see that as continuing through 2022 this year, and maybe for 1 to 2 more years after that. So there's a big push on 5G coverage. The next step will be to increase capacity and look more at those vertical networks where the real promise of 5G will come through. And then about 2028, we'll start looking at 6G proof of concepts and trials going towards commercialization in 2030. So it's good to have that context because it kind of gives you an idea of where ORAN will really fit in a major way. And we don't really see large-scale brownfield ORAN adoption into the latter part of the 5G cycle, edging into 6G. And I think that's not necessarily a controversial statement because all major operators in the world are going through these cycles now with their current vendor systems and not ORAN on a large scale, particularly in ORAN in tier 1 markets. Now, in terms of segmentation, we see, this isn't discussed too much, but it was a little bit by a previous speaker in their keynote. We kind of see that there's 2 big segments of the market, and perhaps greenfields is a little bit in the middle. So tier 1 markets, from the operator perspective, it's a broader ecosystem and perhaps some new capabilities from the SMO and RAPs. But it has a very big demand on it, meaning parity. And this is parity in features, in performance, KPIs, in security, total cost of ownership. And delivering on that parity has a very high demand. So incumbent vendors, there's a very significant R&D investment in here in the order of billions of dollars to meet this parity. So it's a little bit challenging for newer vendors. On the other hand, in private networks and tier 2 markets, such as rural has noted, maybe there's a little bit less of a demand and the focus is perhaps more on the TCO and flexibility. And here the parity requirements are less because there's fewer frequencies, for example. Maybe it's only CBRS, maybe it's only low band. So there's reduced feature demand. Performance could, in theory, be relaxed slightly. and therefore there's an overall less R&D demand for new entrants. And I'm not the only one saying this. So CEO of Benetel, who actually produces ORAN radio units, actually said that they believe that operators go for their main vendors initially, and that their focus will be on these niche markets for private networks and tier 2s. Now, when you start looking at mixing and matching kind of the promise of ORAN, there are some challenges with that. So the first thing is, what is the trigger? So you don't just go and start replacing vendors just because you have ORAN interfaces. There needs to be some significant trigger. The most obvious one is new spectrum, so you have a new deployment, so it's an opportunity to look at new vendors. Perhaps there's a major TCO benefit, although we don't quite see that yet. Or just the desire to have ecosystem verification, just as we do today. Almost every network in the world has at least 2 RAN vendors, and so perhaps having a third gives another option for either price negotiation or keeping everybody honest in terms of feature delivery. The challenges with this approach, though, is that there's new vendor costs, and it creates somewhat complex network design. So on the new vendor costs, these come almost independent of ORAN, but they're a bit exacerbated by ORAN. So new vendor costs, you have to establish new relationships. You have to have a way of working with the new vendor. You have new contracts, new training, new spares, documentation. Systems integration costs and lifecycle management are different for each vendor. So that's true for any new vendor. When you add ORAN into it, then each one of these becomes slightly more complex. So contracts, for example, if you have one RU vendor and a different DU vendor, then you have to have a contract that says you will support a certain version of ORAN fronthaul interface, for example, but those versions change over time. Releases from each vendor aren't delivered at the same time, so you have to be aware of that. Lifecycle management for 2 vendors in the same geographical location will be a bit of a challenge because you're delivering on different times. You may have different delivery mechanisms. So there's this issue of new vendor costs slightly exacerbated by mix and match in the ORAN paradigm. Then in terms of multi-vendor network design, we've kind of gone with this paradigm for the last 3 years that you have a single RAN vendor in a single geography. By that geography, I mean a very large metropolitan area, or in the case of the US, perhaps a state, or even as much as, the West Coast is Ericsson, East Coast is Nokia, or something like that. And this is because it's a lot easier to manage KPIs when you have single vendors in the same geographic area. Things like seamless handoff are much easier. Carrier aggregation, so combining multiple frequencies or having dual and tri-band radios are significantly easier with a single vendor deployment. So when we start looking at mix and matching, we have to consider all these things, and can we really break the paradigm of the last 3 years in terms of network design? So these are some of the challenges we see going forward. So in terms of Ericsson, our focus is first on getting the right building blocks. So we think completing the ORAN specifications to a good maturity level is the priority there, and we're working very hard on that. The other is delivering on that real higher value part on the DU/CU part, which is Cloud RAN, which is somewhat independent of ORAN interfaces. So these are 2 of the important building blocks that we're working on. And then the next is delivering on net new value components. And this comes from the SMO and RAPs. And so we've announced an Ericsson Intelligent Applications Platform, which aligns with the SMO plus some OSS capabilities. And we have RAPs both from Ericsson and partners. 5 were introduced during the announcement, or more are being worked on. So we're getting the building blocks ready towards ORAN solutions going forward. So that's the end of my presentation, and I'm reminded by Peter to ask you or remind you that there's a Q&A section on the left-hand side of your screen, so please feel free to enter questions as we go along here. Thank you.
Wonderful. Thank you as always, Mike. Great to hear from you and the Ericsson team. We're going to head on over now to our live panel. The panel is moderated by Peter Jarek from GSMAI, and he's joined by speakers from the Open Networking Foundation, Deutsche Telekom, Analog Devices, Ericsson, and Sankey Labs. It's a busy one, but I'm sure Peter is up to the task here to get us all the valuable insights that all these experts have to share. As always, do send your questions using the Q&A tab just on the left-hand side of the screen, and that'll help our speakers direct the discussion to the points that you'd like to hear from. All right, Peter, the stage here at 5G Blitz Week is all yours.
Great, thanks a bunch, Alejandro, and thanks to everyone for joining us. I think as Alejandro called out, it's going to be a busy panel, but that's going to make it great because we're going to hear from a lot of really smart folks. Mike said it, Alejandro said it. I'll just remind you all one more time that you can send in your questions. We've already got a few. So Mike and Alejandro have done their job. They've gotten people to send in their questions, so please send in more. I think this is really meant to be an open discussion. I've got a handful of questions that will guide us, but if you guys all send in some, then we can hear from you, or at least get your input. So with that said, what I want to do is, because we have a large set of folk, maybe do a bit of an introduction. And for those of you wondering, you heard Alejandro mention this, and I think you've seen it. We had a last minute, unfortunately, Timon from the ONF can't make it, but that still does leave us with 4 good panelists. So maybe I think we can do a quick set of introductions so people know where you're coming from, know your views. Mike, I know we just heard from you, but maybe you can reintroduce yourself and tell people sort of, obviously we know the Ericsson story, but maybe just a bit about what you're up to there.
Sure. So I'm Mike Murphy. I'm the CTO for North America for Ericsson. And clearly, ORAN is a very big topic for us, so we spend a lot of time on that, both in understanding customer needs and concerns and interfacing back into our product teams.
Wonderful. Thank you very much. Maybe next up, Nick, why don't you talk a bit about what you're up to?
Hi, Nick Carter with Analog Devices. We're one of the leading providers of radio transceiver products that are used in basically all the ORUs or radio units, whether they're Open RAN or not Open RAN. We're a leading provider of these radio transceiver units, and we are a participant and a member of the ORAN Alliance. And in particular, we're active in a couple of working groups that Mike cited, such as Working Group 4 and the Security Task Group.
Great, wonderful. And India, how about you next?
Yeah, thank you. Thanks for introducing me. I am from Sankey Labs. I am the CTO, and I'm managing the RU and the DU products at Sankey Labs, which are primarily focused on the ORAN platform. Currently, we are basically looking at some intelligent ways of how to consider what we call as RAN or DU decomposition in terms of building better and fine-grained resource management, especially for the implementation. Thank you.
Great, wonderful. And last but not least, Franz, why don't you give a bit of a background on what you're up to?
Sure, my pleasure. So I'm Franz Seiser. I'm connected here from Germany, Europe. I'm with Deutsche Telekom, and I'm running we call it RAN desegregation program, which technology-wise builds, of course, on ORAN. What's our relationship to ORAN? Well, Deutsche Telekom is one of the founding operators of the ORAN Alliance. Back in 2018, the CEO of the ORAN Alliance comes from Deutsche Telekom, and we're also part of the MOU group that Atusa from Orange mentioned in the first talk today. So we are extremely strongly committed to make ORAN a deployable reality for brownfield networks in very near future, and also look for sizable deployments to really drive that forward and get the benefits, as described very nicely before by Atusa, realized as soon as possible.
Great. Wonderful. Wonderful. Thank you all. Thanks for being here. And again, thanks to everyone for joining us out in the audience and sending in your questions. So, yeah, I'm going to kick this off. I think if we look at the keynotes that we've had so far, I think you saw a couple common threads in terms of some of the challenges. Maturity was one of them. I think you did a great job, Mike, in calling it out, sort of the development of the standards and specifications, but also integration. And integration was something that was part of what you were calling out, Mike, but also we heard from Matusa. So maybe let's start with integration. I mean, I know that moving from a world of a single vendor solution, and this is one of the questions that came in, right? This idea that the integrator and Open RAN solution is kind of the same as a single solution today. But moving from that to a multi-vendor that may be, ideally multi-vendor, obviously involves some integration challenges. Why when we go out in our research and we talk to operators, and luckily being within GSM Intelligence, we have access to a lot of those. That always comes out as the number one Open RAN deployment challenge, right? So just how do you deal with integration? So just as a reality check, does that match your experience? I know we heard a bit of that from you, Mike, a bit from Atusa. I mean, how are you seeing that as is that the number one challenge? And I know, Mike, we heard from you, but maybe some of the other folks, maybe Franz, just starting with you as an operator, is that what you're seeing as the number one challenge?
Well, it is definitely a challenge. There's no discussion around it, and there is nothing like Freelance, right? If you disaggregate, so tear things apart, that's the easiest thing, and I think all of us know the difficult thing is if you have multiple parts to put something together again and make a working system out of it, and that's not different here. So you need to take certain steps here. The most easy solution, of course, is you take an integrator and say, please do everything for me, like my incumbent radio supplier did in the past. You can do that. You just need to ask yourself, have you gained a lot by doing that? So we don't think that this is the way to go. We strongly believe, or it's a natural consequence, as an operator, you need to take more responsibility yourself. And that's also when you look on the deployment which are out there. Also the already known, which are more brownfieldish, it's always the operator taking more responsibility. So it's not giving everything out, but building, of course, you cannot do that overnight. You need to build the skills, you need to build your organization accordingly, but you need to start the journey. And it's all about really taking part of that responsibility ourselves. It's about finding the right balance. What do you need to do? The RU vendors doing together with the baseband suppliers. Also, how do you get onboarding in the cloud infrastructure done? Sure, but the other part is then who takes responsibility. And by intention, the ORAN architecture has developed a standalone management system, because one of the key pieces is to have an independent management solution, so you can put solutions from different suppliers together without being dependent on someone doing that for you, and you always depend on their speed and their capabilities. So taking that responsibility is absolutely key to make that difference and start to really leverage on the benefits that made possible by this type of architecture.
So I mean, that's a great point. Maybe in India, maybe Nick from your work. I mean, not everyone has the scale or expertise or skills of a larger operator, a larger European operator, like as we hear, the viewpoint from Franz. I mean, how are you seeing that as you work across a broader set of operators and people looking at Open RAN? I mean, are you seeing that same view? What about those other folks that maybe don't have the capabilities to do that integration themselves? How are you seeing the challenges for them?
Sure. I said any emerging technology requires time to mature, and I think that's what you're seeing with these splits. You took a previously integrated protocol stack and are now splitting into 3 distinct functions, and that takes time to mature the interfaces, and the integration is part of that. I mean, there are system integrators in the market who are approaching and solving these problems, but it does take some time to resolve these issues.
That's fair. And India, I don't know if you're back.
Yeah, I'm back. Sorry
So
definitely, multi-vendor integration definitely has been an issue. And as everybody knows, the whole is always greater than the sum of the parts. So definitely in terms of, coming to the question on terms of issue of expertise and skills gap, we find that yes, more and more operators are building expertise to do integration work, and of course, I think we also heard from a previous speaker that large operators are actually having their own in-house integration teams to handle it, handle the complex system issues which needs to be addressed, especially with this disaggregated approach of ORAN. However, if you look at the smaller players and especially in enterprise networks, the play is kind of different, and then this is providing opportunity for system integrators to come in and provide much more specialized skill set and specialized support through providing skill sets to address similar things which a very well ingrained operator does need to provide. So I hope I answered that question regarding the skill sets which are required. No. So we definitely see that there is an issue.
No, that's great, and you did a good job working in. I think one of the questions came in terms of demand for integrators, right? And obviously, too, as you called out, that's going to drive a demand for integrators that understand this stuff. I guess, Mike, maybe going over to you. I think you did a great job of calling out some of the difficulties and challenges in basically just maturing the specifications. I mean, ideally, as we move along that journey to maturing those, it should simplify integration to some extent. Is that fair? So should integration become a little bit easier? I know that you talked about that and Atusa did, but should it become easier as time goes by and those specifications mature as you showed sort of the time frame?
Yes and no. So the yes part is yes, as the specifications mature, then it becomes easier to mix and match vendors. I mean, you could actually do that today without any ORAN specifications, but then you need pairwise agreements and you need willing vendors. So the specifications takes away, let's say, the contractual issue and the negotiation of whose interface to use and all that. However, specifications are never perfect. And so there's still going to be some element of integration between vendors. And also note that, ORAN, you saw we're on version 8 of the fronthaul specification. So the versions keep changing. There's a major new thrust to change the specification yet again to go something beyond 7.2x. So even with stable specifications, you still need to align vendors somewhat in that regard. And everybody so far has been talking about the cost element. So, what are the SI costs? Do we need a third party to do that? Do we need the operator to do it? But there's also a network performance and security aspect about that. So as you mix and match vendors, inevitably, even with great interface specifications, there'll be slightly different performance characteristics and slightly different security aspects as well as others. So we need to be aware of that too, which makes this mix and matching in the same geography slightly challenging.
So I think that leads us into a great set of questions of maybe questions beyond integration, but maybe it also brings up an interesting point. I think you kicked off, Mike, in talking a bit about how Open RAN doesn't imply or doesn't require virtualized RAN, but that seems to be taking place regardless or taking place at the same time. In the same way, Open RAN doesn't necessarily imply multi-vendor, right? I mean, it is one of the main goals, right? But I mean, essentially, Open RAN, we're talking about, essentially open interfaces, which, as I understand, a lot of the folks who do the forecasting and modeling of these assume that a lot of the Open RAN may be single vendor anyway. So I guess how do we maybe, from an Ericsson perspective, I assume you've got some views on that, particularly integration, but maybe across the panel, I mean, how do we expect to see that? I've seen a number of people who basically have, I would say, implied, but have outright stated if it's not multi-vendor, it's not Open RAN. Is that fair, or do you expect to see some Open RAN being single vendor, or at least not as multi-vendor as some people are thinking?
Sure. So,
how are you?
Yes, true. Nobody says it has to be open vendor, but honestly, if you do Open RAN and then buy everything from a single vendor, why the hell? Where is the meaning behind it? So it's not saying everything has to be multi-vendor. So it's perfectly possible that you have baseband and radio units from the same vendor plus some components from other vendors, because they may simply have the better product for certain specific cases. You know, ORAN is not a monolithic thing and one size fits all. There are many different solutions required. Radio units are fundamentally different thing than basebands. So even today we see different suppliers have different strengths, but we always need to take the best compromise, because there is no way to source different solutions from different players. You always have to take one. There is no way to exchange unless, as explained, you go for these extremely painful negotiations. How you do that, which probably is not worth the effort, because you pay a fortune for that. But there is a clear background why we are so much pushing for open fronthaul, because as said, radio units are very different business from baseband, and we see different players with different strengths in those areas, and we simply want to be able to benefit. Still, it's perfectly possible that one player has a good baseband plus radio units which are the best fit for certain deployments, and of course we will take them. Still, they need to fully comply to the open fronthaul specs, because otherwise you wouldn't be able to connect different suppliers. Because the second risk, if you go for single supplier, it will take you 2 months until the first ideas come around. Well, but if we change this a little bit and that a little bit, we get out another 0.5% or whatever. And here you go with the open spec, because you can't, as fast as you look, you suddenly don't have an open interface anymore.
Fair enough. And I think one of the questions coming in on this front, though, is also the question of, if you do, and maybe to the idea of what could you gain even with single vendor, do you get any innovation benefits? Innovation either because now it may be simpler for a given vendor, given the way the interfaces work, or competition, right? When you have more competition, you obviously drive some innovations. I don't know, Nick, do you have any ideas on that, particularly as those solutions are getting developed?
So
Yeah,
I think there's really good questions. There are 2 questions here. Question 1 is the 7.2 interface, which is basically being specified by the ORAN Alliance, independent of multi-vendor, is that a more natural split of an architecture versus maybe all radio, which is kind of a split A today? And with that, I think there are some advantages in where the partition has been defined and what goes into the baseband unit, which are basically in an ORAN nomenclature is known as the DU and CU. The functionality that goes in there can be pooled across multiple radio units. And there is some inherent advantage, at least we think there's some inherent advantage with that split, independent of the multi-vendor aspect, which is the second, I would say, aspect of open radio, which the ORAN Alliance, which is through that interface, being able to mix and match the radio unit with the DU-CU, otherwise known as baseband. I view those as 2 separate but related issues. Does that make sense?
It does. No, it does. I think it's part of how we need to be thinking of this, because I do know there's been some more public out there sort of back and forth about people's open RAN solutions being dinged, particularly deployments when they're not open vendor, or at least multi-vendor rather. And then, yeah, I mean, thoughts on that?
Yes, definitely.
So I think there's some inherent advantages around pooling resources at the baseband unit. I mean, the channel coding and things like that, which are part of the upper PHY, are more centralized in this model, but the actual radio processing is distributed. The actual PHY, the lower PHY, is distributed. And that tends to be fully occupied. So we've done a number of studies on the traffic, and the other question that's correlated with the split is, what does the front haul look like? How much traffic is on there? And the split looks like it works well, the 7.2 split, for what's available today with fiber. I know with massive MIMO, there's some questions, and this is a 64 or 32 antenna solution. There are questions about what functionality belongs in the radio unit, and there's been activities within the ORAN Alliance to look at a different split for those solutions, and there's good technical reason to look at that, one of which is how much traffic you put on the front haul. So these splits, are, from an engineering perspective, look like they're being defined well with engineering criteria as to where you put certain functionality that should be pulled versus distributed, and done with dedicated hardware, which is part of the other aspect, which is the radio unit itself tends to be more dedicated as opposed to virtualized. Yeah, there's a management plane which tends to run an open, an open environment on an ARM core, but the majority of the functions that go into an RU should be hardened to obtain what am I trying to say? To obtain power efficiency. And so these splits look like, the engineering teams that are working on it look like they're taking engineering-driven criteria as to how to define these splits.
No, that's definitely fair. Anindya, I think you had some thoughts there on how you guys see it.
Yes, definitely. I think what we see is that this disaggregation play is giving the best of innovation, to the operators in terms of lowering the TCO, getting the best power and performance benefits, also getting the best of the scaling and the pooling benefits, as rightly mentioned. But there is a balancing act. One of the things that we see is that the balancing act is, how do you enforce a clear set of performance requirements? How do you do a much more granular validation? How do you address integration? One of the things which we started off with, and then the assurance of end-to-end solution is still there. I mean, just because you are taking a disaggregated solution, that doesn't go away. I mean, the operator still has to measure up and serve the KPIs which he has set out to achieve. So essentially, it becomes a balancing act. But then, with the introduction of a lot of system integrators coming in, we find that they are trying to address these kind of gaps. They are trying to address scale. They are doing more validation, more probably beyond what the interoperability specs allow, and also addressing very critical issues like life cycle management and things like that, which are also critical in this scenario, especially when you're taking a disaggregated approach. So I feel the approach has to be a little bit balanced. It is not really tilted towards one side as to go pure disaggregated, because finally the KPIs of the network really are what matters.
Great. No, that's fair enough. I mean, Mike, what I'm struck by, and I get it because it makes sense in terms of how we're thinking of solutions. This, if we look back at just a bit of the response to the discussion on sort of multi-vendor versus single vendor, a lot of it's been focused on the CU versus DU and pulling in radios. But I think as you called out, right, there's a whole lot of value that can be done from the management, from the operations, and you talked a bit about the work that you guys are doing in sort of the RIC domain. So I think maybe this is a natural sort of switching off place of how we can think about that, particularly in terms of multi-vendor. And this loops in maybe some thoughts there in terms of how you see sort of the struggles of multi-vendor if we're talking about CU versus DU and the radio units versus the RIC. And then sort of a question of, if we look to the audience questions, one of the questions of how at Ericsson, you guys have chosen to focus on the R apps and not the X apps, and where you see that being, which you see being more beneficial.
Sure. I think as a rule of thumb, the higher you go up the chain, perhaps the easier it is to have multi-vendor. So RUDU is a very complex one. Getting to the SMO is perhaps somewhat easier. And as I noted in my keynote, I mean, we see that especially the RApps provide a net new value that we don't quite have today. You have SON applications, but the interfaces in ORAN are perhaps a little bit richer, and they're more enabling for a multi-vendor situation. And there's a lot of great companies out there developing them. So I think that's more of the net new value from our perspective. And going to RUDU mix and matching, less so, and it provides more of the ecosystem benefits. With respect to ARPs versus XApps, it's also a little bit like I started off with, that it's easier when you go up the change to add in multi-vendor solutions. The lower you get down to, especially layer 1, then things become more complex. And our view is that the XApps are challenging in that way because they get so close to the inherent performance of the base station at the DU level that you could end up having challenges, almost conflicts between what the DU supplier is providing and what the XApps are trying to do. So it's a little bit easier to do that at the RApp level. And you get essentially almost every app we've looked at, you can implement large parts of it at an RApp level without having to go down to the XApp level.
So it sort of speaks to that maturity issue and sort of what is starting where we can get value for things that are, we at least probably know have a better chance of working. Is that fair?
Yes, that's fair. And also, there's something new introduced by RApps and SMO. There's nothing really new introduced by a new fronthaul interface. There's not a huge performance gain. There's not a huge security gain, at least not yet. And so it's really ecosystem evolution, which has value, obviously, but not in terms of, like I mentioned earlier, if you wanted to create a more competitive network, that won't necessarily do it.
Well, and it's a good shout because I think, and you made reference to this, right? I think a lot of the early discussion around Open RAN really did focus on cost, right? You could try and figure out, the decreased cost in operations, the decreased cost in equipment. And I think there was some back and forth. We've heard from operators who question that, particularly when you add in outside integration costs. And so, we are seeing this discussion of is the value really more around that core infrastructure, the CUs and the DUs, or around the innovation you can have by bringing in third-party folks at that SMO and RIC layer. I mean, maybe Franz, from your perspective, we're sort of talking about those as separate, right? Talking about the CUs and the core sort of the actual RAN infrastructure versus the management. Is that a fair way to look at it, or should we be thinking about those more holistically?
Well, there is value in both. I have to say, of course, RApps and XApps will deliver a complete new level of innovation in the way I typically describe it. It makes the radio a programmable platform with APIs, and you're able to develop applications on top. Of course, that requires a certain support from a CU/DU side, as if you don't open up certain functionality as just described, then you can't influence. So this will be still a discussion going forward, because of course you also don't want to end up in if too many captains want to steer a ship, it's not sure it's going into the right direction. So that's for sure needs some more thoughts. But we also see by opening up the infrastructure, this creates competition, and competition helps. There are simply what we see in the meantime, there are only very few radio suppliers left, and we are fully dependent on their development speed. And the one with the deepest pockets obviously gets the highest chance to get things done. And this is more and more of a pain because simply the number of players are shrinking, so you have less opportunity. And I know that from my own, if I think back when I joined the industry, this was when we just started talking about 3G. That's the technology some of you still may remember. We are switching off in many markets now. I needed two hands to count the number of radio suppliers we could negotiate. Today I'm fine with one hand. And so and competition helps. We all know more competition drives innovation, people coming up with new ideas. What we have seen in Barcelona, also behind closed doors to a certain extent, what's in the pipeline, what people are coming and thinking about. This gives a complete new wave of people coming in with new ideas and different thinking, because they suddenly see a market opening up. And that, as we are still today mainly discussing separating baseband from radio units and opening up here and making more a software play, which gives a complete different type of companies an opportunity to get into that market. And we see quite a lot of interest and solutions coming around. Along this one, together with quite a lot of competition now starting to build on the hardware side. We know today it's limited, but we see multiple companies who have been there in the past, who come back now, or now starting to develop silicon, gives a complete new level of competition and solutions out there. So I have pretty high expectations that this will be a very fundamentally different world in 1.5 to 2 years from today.
So it looks like we've probably got about 15 minutes left, and so I want to make sure we address, and we're integrating the questions from the Q&A, but please send in some more because I think they're really instructive and they're fitting well with the conversation. But so we talked a lot about integration and maybe how it could be simpler in some of the business models, but I think across both of the keynotes, I think one of the topics that came up, we could talk about maturity of the specs, but also performance, right? And I think I tend to think of those in a similar way, right? It's really talking about maturity of the ecosystem. Obviously, as Mike called it, the specs are evolving, but at the same time, the ecosystem is maturing, and there are issues like performance, right? I think that's well understood, whether it's in terms of energy efficiency, whether it's in terms of spectral efficiency, whether it's in terms of just the ecosystem completeness. We know that Open RAN isn't quite at the same place as traditional RAN, which anyone who would think that it should be would be crazy. I mean, it's a new development. I think anytime you have a new development, it does take time to develop. But maybe Anindya, maybe you can start. I mean, how are you seeing performance? How are you seeing the maturity of the ecosystem? And I think Mike did a good job covering maturity of the specs and how they're evolving. But from the ecosystem and the performance development of the solutions, what's your perspective on that, and how do you see that evolving from a time scale?
Yeah, I think what we are finding in our interaction with the vendors is that actually, essentially, people are asking the same specifications that they were asking the traditional RAN vendors. So there is actually no let up in the specification that is being demanded by the carriers or by the different players. The specifications demanded are the same, but yes, there is a gap in terms of how it can be addressed, because a lot of the specifications which are being asked, people are telling us that traditional vendors used to provide this, and hence even though you are an ORAN vendor, you need to provide that, because people are looking at in terms of the KPIs that the network has to really cater to, and that is something which we understand while there is a gap, but that is something which at least the carriers in India whom we see, they find that is something which they cannot let go. Now, having said that, we find that essentially, I think this was addressed in Mike's keynote as well, is that we see two classes. One is the traditional tier 1 class, where the specifications are very, very tight, and there is probably not so much leeway to maneuver around and cater to that. But then if you look at the enterprise or the smaller vendors who are catering to I would say smaller networks, not really the large scale networks, there we find some room to play around, and that is where there is some opportunity that we see, where the specifications that are there today can help one make a dent. So I would say it is in the process of evolution. The radio specifications, the DU specifications, each of them are in the process of evolution. They are getting matured. We find that a lot of real world things. For example, if I look at TDD, the way ducting, for example, I'm just taking case in point, used to be addressed by traditional RAN vendors. If you look at ORAN, that is not addressed today. There are several holes like that which are yet to be addressed. And I think somebody also spoke about security. A lot of those things are yet to be addressed by ORAN, and people are gradually finding that those are making way into by different working groups. The other example is the massive MIMO case, where people are relooking at the splits that the ORAN 7.2x splits. There is definitely some. I mean, people are realizing that there is performance left on the table if you cater to to the 7.2 experts and people are finding out that that may not be the right split if you really want to cater to a very wide class of markets. So my take is that ORAN specification as it exists today is not perfect for what the traditional operators have been looking at, because they don't want to let go the performance or the KPIs of the network just because ORAN has come in. They are looking at it in the classical sense and says, this is what my customer wants. I want this much spectral efficiency, and how do I get it? They are thinking that yes, ORAN will give me some benefits of disaggregation because more players are coming, more innovation will happen. So they are actually, we find that the demand is more in terms of the specification. There is no let up just because ORAN is there.
So I think that leads us into a good maybe final question, and one with a sort of final question. It kind of goes back to a bit of what you were calling out, Mike. But we'll start with Nick. I mean, in a bunch of I think I've seen some of the questions in here as well, sort of focused on this question of when do we think that we'll actually see Open RAN be competitive with traditional RAN, or whatever we want to call it. I think that's another struggle the industry is trying to figure out. What do we call sort of non-Open RAN? But there's a couple of questions here, right? When do we think that Open RAN will go from just being a focus on greenfield to ubiquitous for everyone? And another question coming in of when do we think we'll have solutions similar with features to traditional RAN, meaning massive MIMO at 32 by 32, or I'd say 64 by 64. But really, it comes down to the question of when do we expect, and we can use Mike's discussion of specs development, the time frame there, but when do we expect solutions will be on par with traditional RAN, so that operators don't kind of have to make that choice? And maybe Nick we'll kick it off with you and then go around the rest of the panel.
Okay, I've been in the industry too long to give you dates, but I'll give you directionality. And I have to keep going back to a statement I alluded to earlier about being very articulate with it now, which is ORAN is a technology, and underneath it there's a lot of objectives, one of which is these architectural splits. Another is the multi-vendor environment. ORAN as a technology delivered by more established vendors will occur first. And eventually it'll expand as it matures into a greater vendor community. But I think ORAN, the technology, as manifests with maybe the tier ones that are the more established vendors, will be the way it rolls out first. I can't give you a timeline. There's still some things that have to be done in the standards bodies, but that's what I'm saying is not rocket science. That's the way these things have typically rolled out over time.
I think that's fair enough. Anindya, why don't you pick up time frame? Nick's not willing to put a date on it. I think as being an analyst, I think unfortunately sometimes my team doesn't have that luxury. We have to put dates on things. Date-wise in India, when do you think Open RAN will be competitive with non-Open RAN or traditional RAN solutions?
Yeah, so I think, yes, it is. We have to do a little bit of stargazing there. I think if we look at the different components, probably, if I look at the RU, we see that, yes, there are definitely a lot of players there. DU, one of the things I see is that the hardware platforms are very few today, in fact, but then we see a lot of hardware platforms coming up in the pipeline. And that I think is probably 2 to 3 years away when we see a proliferation of different hardware platforms. A lot of silicon vendors are building more and more platforms, and that is something which will come. So I would say that would take maybe 2 to 3 years. CU, I think, probably is already at a point where I think it is fairly mature in terms of the hardware platform, but yes, the features and all, I think will come in terms of the software upgrades and 3GPP upgrades that are coming in. So I feel overall the different components are in different stages of progression, if you will. And And I think other than that, I don't have a very straightforward answer to this.
No worries. No worries, Franz. Does that match as you look out and you're pushing on? I think you mentioned you're seeing some great innovation. You're seeing different vendors to work with. You're hopefully moving from one hand to 1.5 hands that you can count folks on. Do those timelines sort of match what you're seeing?
Well, as I said, we are looking pretty intensely. I would say for classical 4x4 deployments, we are basically there today, and it's deployed large scale in other parts of the world. So there is nothing hindering that. So that is what we have seen. This is basically on eye level. Of course, it always depends a bit with whom you choose. Not everyone is exactly on the same level, but it is within a few percentage points, I would say. The challenge, as said multiple times, is of course massive MIMO. And that's why also, as said earlier, there is a discussion now kicked off in ORAN Alliance to see how we need to adapt the open fronthaul to increase performance there. And it strongly depends how quickly there is agreement in the ORAN Alliance. But I'm still very hopeful that by mid of this, or even before mid of this century, we should have a full one-to-one replacement of SRAN. So it should be really up on eye level and competitive by that point in time.
Great. And Mike, last word goes to you. I know we heard you were pretty clear and straightforward in terms of the timing for the spec development. I know Ericsson has sort of made that connection to 6G sort of timing as well. From your perspective, is that still when we should expect solutions to be competitive, or do you think it'll even push beyond that?
So first, I agree with all the previous speakers on their comments, meaning that there's different timelines for different components, even on the RU, so 4x4 versus 32X or 64 TRX. From a spec perspective, we kind of see, security being a big one and the new fronthaul being another big one. And our view is that roughly around 2024, which kind of agrees with Franz there, that those will hit a maturity level. And there's a lot of, most of the customers around the world have made incumbent contracts for some periods, 3 years, 5 years. So all of that, putting it together means, probably we're not going to see large scale brownfield until post 2024, 25. And then we get edging into the 6G area. So that was the logic to my timeline schedule before. So in general, of course, there's always exceptions and you see smaller deployments, but large scale, I think it really is getting closer to the 6G area.
And I think it's an important reminder, right, that obviously there's a difference between sort of broad scale and early on. And I think as was mentioned, I think it was you mentioned earlier, Franz, you've got to start somewhere, right? We can't keep talking about tomorrow and tomorrow and tomorrow, but also recognize that you can't necessarily get there tomorrow. You've got to start, and it will scale up over time. Well, thank you to all the panelists. Thanks to everyone who joined us. If we didn't get to your questions, apologies, but we'll try and follow up, I guess, with some of those afterwards. Thank you all very much, and back to you, Alejandro.
Great. Thank you so much, Peter, and of course to all of our panelists for that great session and to all the questions coming in as well. Right, we're going to now head on to our closing keynote for this morning session on Open RAN, and we'll be hearing from Reza Vaezghemi, and he is a senior manager for PLM over at Viavi Solutions. Reza, over to you.
Welcome to this keynote on the addressing Open RAN deployment challenges and opportunities. My background is from the transport and synchronization, so I'm going to focus on the aspects, the challenges and opportunities that we have in the transport and synchronization. Hopefully, they will be useful for you today. As you will see, we have a number of new challenges coming on, and I think that we are learning a lot as we go, right, in these different activities, in test events, PlugFest, and that's what we're going to talk about today. So first of all, let's start with the basic, right? So what are the basics? 5G, we all know, poses new challenges because we are dealing with higher bandwidth. of course, 5G has other aspects as well as in ultra low latency and massive machine time communication. For today, given the limited time we have, I'm going to focus on the EMBB applications, right? Massive broadband applications that we have. So bandwidth, we are going to talk about today. We know that's available, but mostly in mid-band and high band, right? That's why we are so dependent on massive MIMO and beamform technologies. So what does it mean now for X-Haul? X-Haul being backhaul, mid-haul, front haul, and we are going to focus actually on front haul. That's where most of the volumes are and the concerns of the operators. So in 4G, we are all aware of the CPRI, Common Public Radio Interface. Very simple synchronized interface is a TDM technology that allowed us to connect a large number of radio units or RRH with baseband units. That allowed us to deploy these radios at many different locations and have all the intelligence and power and backup, etc. utilities in a distant location. That was CRAN, right? Or is CRAN still being deployed? But what is now new? The new thing is that with 5G now we need, and with massive MIMO especially, we need now a new split option, lower layer split option that allows us to deal with these massive bandwidths, right? That 5G demands. This new lower layer split option is known as also 7.2x or 7-2x, also known as eCPRI. This is a packet-based technology. It's not TDM anymore. It's packet-based technology. And in addition to that, we know packet-based technologies themselves don't deliver synchronization as in time phase or time of the day, right? So we are either dependent on having to deploy GNSS at every radio, a possibility, but very expensive one, or be dependent on network-based timing, which is precision time protocol, also known as 1582, IEEE 1582 version 2 for phase time, and then strongly recommend to be complemented by synchronous Ethernet, which delivers this physical layer synchronization for frequency. These are highly recommended. Operators may still decide to deploy GPS, like I said, but this is what we all see as mainstream. So this is the lower layer split. Let's see what it means in terms of challenges for X-Haul. First of all, what are some of those X-Haul technologies? We start here. So this is backhaul, mid-haul, front haul, right? And physical layer given, we need physical either dark fiber, which is okay for low scale deployment, but for larger number of radios, we need more scalable solution. WDM is becoming more and more mainstream. It has been actually going on for several years now. Really nothing new. CWDM, DWDM, or MWDM in Eastern Asia for front haul. For backhaul and mid-haul, PON wireless and DOCS is certainly being deployed, and there are many new products and new technologies that are being introduced by vendors to make them even adoptable and useful in front haul. Front haul poses new challenges we are going to talk about, and so it's not always given that we can deploy these technologies in front haul. But again, great work is going on, being products already in the market that address some of these limitations and challenges that front haul poses here in these new products. I'm not going to focus a lot today on these technologies. Really talk about packet-based. And we knew that from 4G. We basically the same kind of life cycle, same type of basically technology rollout that we saw in 4G. First with WDM, and then we had to go with packet-based, right? And why packet-based? Because packet-based offers us the statistical multiplexing. Statistical multiplexing now is obviously very valuable if you are dealing with variable traffic. And eCPRI is a variable bitrate traffic, unlike CPRI. So it's very obvious that a packet-based technology would be a very strong candidate for the front haul networks. And that is what we are starting to see certainly in some operators, but also in labs, that operators looking at deploying either layer 2 based technology, Ethernet, or even IP, right? And or combination with MPLS, with Ethernet being the overwhelming majority. The challenges that come with PTP and also here packet-based technology is the ones of latency, right? So one-way frame latency is very important. That is already being introduced by the physical network, right? So physical network already itself brings limitations. So just fiber alone, right? We can't go beyond certain limits. One-way frame latency already being kind of introduced by physical network technologies. When we deploy packet, now we need to look at some other challenges, which is frame loss ratio, synchronization, and we're going to talk about some of these details. And so these are interesting things, challenges that we need to watch for as we start to deploy packet-based technologies. So let's talk about some of these aspects here. First of all, this is a reference model from ORAN that many of you are aware of. So the distributed unit RU, again, front haul here. In this case, we are deploying a couple routers, cell-side router, hub-side router. Could be more if we can afford it, right? There are formulas and recommendation made in ORAN and other organizations about how to calculate the number of routers. Invite you to check those specifications in ORAN that are now public, working group 4 and working group 9. So these are the technologies that we are talking about that are going to introduce some new challenges beyond physical layer. So let's take a look at some of these challenges. We have M-plane here. M-plane is basically the management plane, right? That introduces this secure session, so the management information can be carried forward. So that's not going to be the major topic we're going to talk about. Most of the challenges that I see, at least from my perspective, are control user plane and S-plane. Control user plane, it's basically the user planes carry the IQ samples, and control plane characterize basically the slot, in the radio frame slot, where the radio frames and the IQ samples are carried. And this is an important topic. Now, in ORAN, for example, we have what is called these delay management profiles that define what is the difference between the user planes, the arrival time of user planes, and the respective control planes. In other words, the user planes cannot arrive too early or too late at the radio. If they arrive too early or too late at the radio or on the uplinks part of it at the DU, then the DU won't be able to make sense of it, or the same with RU. The job of the RU, let's focus on RU, is to take these packets, controlling user plane that are frequency domain IQ, make sure it can reassemble that, translate it to time domain IQ data, and that's what goes out of the air, right? So if these packets don't meet the delay aspects, the relative delay, and then the radio will have a problem with it. So we need to follow that. The second topic is synchronization. As we all know, full timing support is strongly recommended by ORAN. It's not required, but it's strongly recommended. GA75.1 profile in ITUT. SYNC is also optional, highly recommended as a way of having a very stable frequency, also as a backup to provide some limited capability in case of holdovers. So we are going to talk about as well, because both of them are now going to face challenges that we need to address. So let's talk about some of them and how we can address these basically challenges that we see. The first thing is the one-way frame latency. We said this is already given by physical layer, very critical for the operation of the MAC layer. We thought we had it already with with the 4G, and same thing with 5G. We have this limit IEEE and ORAN. We define 100 microsecond for one-way frame latency, 200 microsecond for two-way latency between the U and I interfaces. Those need to be measured and very critical for Mac operation. It sounds maybe simple. What can go wrong, right? Just a frame latency measurement. But you all know, once you deploy routers, the routers have their own challenges. We have buffers, we have packet delay variations, and they become very interesting, especially if you have congestion on the network, right? Large frame sizes, all we know. Those, we need to make sure that we measure those not only under ideal condition, but also at nominal or stress condition. Make sure those one-way frame latency, the one-way, is not exceeded. The other topic is the relative delay measurement between the C and user plane packets. Make sure that those don't arrive too early or too late, right? Either at RU or at the GU. Again, it may sound simple, but we need to make sure this is happening in with not only ideal condition, but nominal and even better with stress patterns, so that we can make sure that happens when there is extreme traffic and those packet times are observed. And finally, let's talk about time error. The 3GPP, we all know, defined several categories. The category C is already relevant for TDD type of services. Category B and A become more relevant when you are talking about carrier aggregation, the contiguous or non-contiguous carrier aggregation, and A+ is, one example is the MIMO transmit diversity. I think we are thinking that for networking short term, probably these are the mainstream ones. A+ probably more relevant when we talk about co-located radio. But even when we talk about B and A, the time alignment error limits defined by 3GP are very, very challenging. We talk about 260 nanosecond, the relative time error between two antenna ports, or 130 for category A. That's compared with 3 microsecond in category C. So you see where we are talking about the big challenges right here. That's something we certainly need to watch, make sure that this is observed. There are two different metrics we are talking about. The time alignment error are relative to the antenna ports over the air, and then we have time errors that are defined for the user interface, for example, for front haul or mid haul, back haul, the same thing, but they define the limits here for the U and Is, right? In ORAN and IT, we have limits. I invite you to check the papers in working groups 4 and 9 on the limits for the time error, either absolute time error, which defines the time difference between the UNI and the GNSS, or the relative time error between two UNI interfaces. This is a simple diagram. We all know the reality is more complex, but I hope this keynote provided some input to understand some of these challenges and opportunities we have in deployment of ORAN networks. With this, I would like to close for today. Thank you for your attention and have a great rest of the day with this event. Thank you.
Thank you so much, Reza, for that great presentation, and of course to all of our speakers and panelists for this session. Really getting day 2 here started with a very high caliber indeed. Before we wrap up here, a special thank you to our partners, Analog Devices, Ericsson, Sankhya Labs, and Viavi Solutions. Right, well, of course, the day is far from over here, so we hope you can join us for our next session. It'll start up at 2 p.m. Eastern, and we'll be talking about 5G and fixed wireless access and its role in bridging the digital divide. Plenty to discuss there. Until then, thank you again for joining us, and take care.